Hi, welcome to Conquer the Concept, and in this video we'll be discussing about geometric progressions. The standard form of the geometric progression is a times r, a times r squared, and then a times r cubed, where a is the first term, ar is the second term, ar squared is the third term, and ar cubed is the fourth term. And just something to keep in mind is that the third term had r to the power of 2 and not 3. It's a common mistake that people make. A is the first term, r is the common ratio, and a subscript n, where n is any number, is equal to a times r to the power of n minus 1. And we'll discuss that later in the video. So let's identify a and r in an example sequence. In this sequence, it goes like 3, 15, 75, 375. And in the standard form, a is the first term and 3 is the first term in this sequence. So a is 3 in this example. And the second term in standard form is ar. And in this example, the second term is 15. The 15 is equal to ar, and we can substitute 3 in this equation, and we would get 15 is equal to 3 times r, and then divide by 3 and you get 5 is equal to r, the common ratio. And the common ratio just means what you are multiplying one number by a number in the sequence by to get to the next number. So, for example, you would multiply 3 by the common ratio of 5 to get to 15, and 15 by 5 to get to 75, and then so on. So if you're looking to find the sum of the geometric progression, you can use this formula. It is a times 1 minus r to the power of n whole divided by 1 minus r. You could also switch up the places of r and n to get a times rn to the power of n minus 1 divided by r minus 1. And a represents the first term, r represents the common ratio, and n represents the number of terms. Let's try an example problem. So the problem is asking, find the common ratio, the ninth term, and the sum of the terms of a geometric progression where the first term is 3 and the fourth term is 24. There are a total of 10 terms. So let's find the common ratio first. So we already know that a is equal to 3 because it says that the first term, a, is equal to 3. So, and the fourth term is equal to 24. So a subscript 4 is equal to, if we use the formula that we saw earlier in the video, it's a times r and then 4 minus 1. So this is equal to a times r cubed. And if we substitute 3r cubed, and this is the standard, ar cubed is the standard form for the fourth term. And the fourth term in this example is 24. So 3r cubed is equal to 24, and then r cubed is equal to 8, and cube root of 8 is equal to 2, so r is equal to 2. So we just found, we know what the a is and what r is. R is equal to 2, and the a is equal to 3. So we can cross off this, and the next thing that we need to find is the ninth term. And so we can use the formula again. A subscript 9 is equal to a times r and 9 minus 1. And this is equal to a times r to the power of 8. And we can substitute a and r. So this is 3 times r times 2 to the power of 8 times 2 times 2 to the power of 8. 2 to the power of 8 is 256 times 3. We can do that really quickly. 3 times 6 is 8, and then carry over the 1. 3 times 5 is 15, 15 plus 1 is 6. 56, and then carry over the 1, and then 3 times 2 is 6, 6 plus 1 is 7, so 768 is the 9th number. So we can erase this. And lastly, what we have to find out is the sum of the sequence, and we were given a formula to find that. So the formula is right here, and we can switch up the terms, and we can use that formula to find the sum. So a times r to the power of n minus 1 divided by r minus 1, and just substitute the values. So 3 times 2, and then n is the number of numbers, the number of terms, and the last sentence of the problem says that there are a total of 10 terms. So we can just use that 10 minus 1, and then r is 2, and then that minus 1, and then we can just evaluate this. So this would become 3 times 1024, or 1024 minus 1 over 1, and then this would become 3 times 1023, and then we can just do that. 1023 times 3 is equal to 9. 3 times 3 is 9. 3 times 2 is 6. 3 times 0 is 0. 3 times 1 is 3. So 3,069, is our sum of the geometric regression. If you learned from this video, please like and subscribe to Conquer the Concept, and comment down below. Thank you for watching.